CIET NCERT presents the audiobook Ganit Prakash, Textbook of Mathematics for Class 6.
Chapter 2 Lines and Angles. Page number 13. In this chapter, we will explore some of the most basic ideas of geometry, including points, lines, rays, line segments, and angles. These ideas form the building blocks of plane geometry and will help us in understanding more advanced topics in geometry, such as the construction and analysis of different shapes. 2.1 Point. Mark a dot on the paper with a sharp tip of a pencil. The sharper the tip, the thinner will be the dot. This tiny dot will give you an idea of a point. A point determines a precise location, but it has no length, breadth, or height. Some models for a point are given here: the tip of a compass, the sharpened end of a pencil, the pointed end of a needle. If you mark 3 points on a piece of paper, you may be required to distinguish these 3 points. For this purpose, each of the 3 points may be denoted by a single capital letter such as Z, P, and T. These points are read as point Z, point P, and point T. Of course, the dots represent precise locations and must be imagined to be invisibly thin. Page number 14. 2.2 Line segment. Fold a piece of paper and unfold it. Observe crease. This gives the idea of a line segment. It has 2 endpoints A and B. Mark any 2 points A and B on a sheet of paper. Please try to connect A to B by various routes. What is the shortest route from A to B? This shortest path from point A to point B, including A and B, are here, is called the line segment from A to B. It is denoted by either AB or BA. The points A and B are called the endpoints of the line segment AB. 2.3 Line. Imagine that the line segment from A to B, that is AB, is extended beyond A in one direction and beyond B in the other direction without any end. You can observe in the figure. This is a model of a line. Do you think you can draw a complete picture of a line? No. Why? A line through 2 points A and B is written as AB. It extends forever in both directions. Sometimes a line is denoted by a letter like L or M. Observe that any 2 points determine a unique line that passes through both of them. Page number 15. 2.4 Ray. A ray is a portion of a line that starts at one point, called the starting point or initial point of the ray, and goes on endlessly in a direction. The following are some models for a ray: beam of light from a lighthouse, ray of light from a torch, sun rays. Observe figure given of a ray. You can find the figures of a ray. 2 points are marked on it. One is the starting point A and the other is a point P on the path of a ray. We then denote the ray by AP with an arrow. Figure it out. First, Rihan marked a point on a piece of paper. How many lines can he draw that pass through the point? Sheetal marked 2 points on a piece of paper. How many different lines can she draw that pass through both of the points? Can you help Rihan and Sheetal find their answers. Page number 16. Question number 2. Figure 2.4. Name the line segments in the figure. Which of the 5 marked points are on exactly one of the line segments? Which are on 2 of the line segments? Question number 3. Name the rays. Figure 2.5. Is T the starting point of each of these rays? Question number 4. Draw a rough figure and write labels appropriately to illustrate each of the following. A, OP and OQ meet at O. B, XY and PQ intersect at point M. C, line L contains points E and F but not point E. D, point P lies on AB. Question number 5. In figure, name 2.6. A. 5 points. B. A line. C. 4 rays. D. 5 line segments. Page number 17. Question number 6. Figure 2.7. Here is a ray OA. It starts at O and passes through the point A. It also passes through the point B, part A. Can you also name it as OB? Why? Part B. Can you write OA as AO? Why or why not? 2.5. Angle. An angle is formed by 2 rays having a common starting point. Here is an angle formed by rays BD and BE, where B is the common starting point, figure 2.8. The point B is called the vertex of the angle and the rays BD and BE are called the arms of the angle. How could we name this angle? We can simply use the vertex and say that it is the angle B. To be clearer, we use a point on each of the arms together with the vertex to name the angle. In this case, we name the angle as angle DBE or angle EBD. The word angle may be replaced by the symbol, that is angle DBE or angle EBD. Note that in specifying the angle, the vertex is always written as the middle letter. To indicate an angle, we use a small curve at the vertex. Refer to the figure 2.9. Vidya has just opened her book. Let us observe her opening the cover of the book in different scenarios. Case 1, Case 2, Case 3, Case 4, Case 5 and Case 6. Page number 18. Do you see angles being made in each of these cases? Can you mark their arms and vertex? Which angle is greater? The angle in case 1 or the angle in case 2? Just as we talk about the size of a line based on its length, we also talk about the size of an angle based on its amount of rotation. So, the angle in case 2 is greater, as in this case she needs to rotate the cover more. Similarly, the angle in case 3 is even larger than that of case 2 because there is even more rotation, and cases 4, 5 and 6 are successively larger angles with more and more rotation. The size of an angle is the amount of rotation or turn that is needed about the vertex to move the first ray to the second ray. You can find the figure on page as 2.9. Let's find at some other examples where angles arise in real life by rotation or turn. In a compass or divider, we turn the arms to form an angle. The vertex is the point where the two arms are joined. Identify the arms and vertex of the angle. A pair of scissors has two blades. When we open them or turn them to cut something, the blades form an angle. Identify the arms and the vertex of the angle. Page number 19. You can find the pictures of spectacles, wallet, and other common objects. Identify the angles in them by marking out their arms and vertices. Do you see how these angles are formed by turning one arm with respect to the other? Teacher's note. Teachers need to organize various activities with the students to recognize the size of an angle as a measure of rotation. Figure it out. First question, can you find the angles in the picture? Draw the rays forming any one of the angles and name the vertex of the angle. You can find a picture of a cycle and a board on this page. Page number 20. Question number 2. Draw and label an angle with arms ST and SR. Question number 3. Explain why angle APC cannot be labeled as angle P. Question number 4. Name the angles marked in the given figure. Question number 5. Mark any 3 points on your paper that are not on one line. Label them A, B, C. Draw all possible lines going through pairs of these points. How many lines do you get? Name them. How many angles can you name using A, B, and C? Write them down and mark each of them with a curve as in figure 2.9. Page number 21. Question number 6. Now mark any 4 points on your paper so that no 3 of them are on one line. Label them A, B, C, D. Draw all possible lines going through pairs of these points. How many lines do you get? Name them. How many angles can you name using A, B, C, D? Write them all down and mark each of them with a curve as in figure 2.9. 2.6. Comparing angles. Opening their mouths. Do you see any angles here? If yes, mark the arms and vertex of each one. Some mouths are open wider than others. The more the turning of the jaws, the larger the angle. Can you arrange the angles in this picture from smallest to largest? Is it always easy to compare two angles? Here are some angles. Label each of the angles. How will you compare them? Draw a few more angles, label them and compare. Page number 22. Comparing angles by superimposition. Any two angles can be compared by placing them one over the other, that is, by superimposition. While superimposing, the vertices of the angles must overlap. After superimposition, it becomes clear which angle is smaller and which is larger. The picture given here represents two angles superimposed. It is now clear that angle PQR is larger than angle ABC. Equal angles. Now consider angle AOB and angle XOY in the figure. Which is greater? We can find here three pictures with angle AOB, angle XOY, and another one with angles superimposed. The corners of both these angles match and the arms overlap with each other. That is OA with OX and OB with OY. So, the angles are equal in size. The reason these angles are considered to be equal in size is because when we visualize each of these angles as being formed out of rotation, we can see that there is an equal amount of rotation needed to move OB to OA and OY to OX. From the point of view of superimposition, when two angles are superimposed and the common vertex and the two rays of both angles lie on top of each other, then the sizes of the angles are equal. Page number 23. Where else do we use superimposition to compare? Figure it out. Question number 1. Fold a rectangular sheet of paper, then draw a line along the fold created. Name and compare the angles formed between the fold and the sides of the paper. Make different angles by folding a rectangular sheet of paper and compare the angles. Which is the largest and smallest angle you made? Question number 2. In each case, determine which angle is greater and why. First part A, angle AOB or angle XOY. Second part B, angle AOB or angle XOB. Part C, angle XOB or angle XOC. Discuss with your friends on how you decided which one is greater. You can find a picture on page 23 here showing different angles. Question number 3. Which angle is greater? Angle XOY or angle AOB? Give reasons. You can find a picture representing angle XOY, angle AOY and BOY. Comparing angles without superimposition. Two cranes are arguing about who can open their mouth wider. That is, who is making a bigger angle. Let us first draw their angles. How do we know which one is bigger? As before, one could trace these angles, superimpose them and then check. But can we do it without superimposition? Page number 24. Suppose we have a transparent circle which can be moved and placed on figures. Can we use this for comparison? Let us place the circular paper on the angle made by the first crane. The circle is placed in such a way that its center is on the vertex of the angle. Let us mark the points A and B on the edge circle at the points where the arms of the angle pass through the circle. We can find here two pictures, AOB and center O with 2 points A and B on the circle. Can we use this to find out if this angle is greater than or equal to or smaller than the angle made by the second crane? Let us place it on the angle made by the second crane so that the vertex coincides with the center of the circle and one of the arms passes through OA. Can you now tell which angle is bigger? Page number 25. Which crane was making the bigger angle? If you can make a circular piece of transparent paper, try this method to compare the angles in figure 2.10 with each other. Teacher's note. A teacher needs to check the understanding of the students around the notion of an angle. Sometimes students might think that increasing the length of the arms of the angle increases the angle. For this, various situations should be posed to the students to check their understanding on the same. 2.7 Making rotating arms. Let us make rotating arms using two paper straws and a paper clip by following these steps. First one, take two paper straws and a paper clip. Second step, insert the straws into the arms of the paper clip. Step 3, your rotating arm is ready. Make several rotating arms with different angles between the arms. Arrange the angles you have made from smallest to largest by comparing and using superimposition. Passing through a slit. Collect a number of rotating arms with different angles. Do not rotate any of the rotating arms during this activity. Page number 26. Take a cardboard and make an angle shaped slit as given here by tracing and cutting out the shape of one of the rotating arms. Now, shuffle and mix up all the rotating arms. Can you identify which of the following rotating arms will pass through the slit? The correct one can be found by placing each of the rotating arms over the slit. Let us do this for some of the rotating arms. Slit angle is greater than the arm's angle. The arms will not go through the slit. In the second one, slit angle is less than the arm's angle. The arms will not go through the slit. In the third one, the slit angle is equal to the arm's angle. The arms will go through the slit. Only the pair of rotating arms where the angle is equal to that of the slit passes through the slit. Note that the possibility of passing through the slit depends only on the angle between the rotating arms and not on their lengths, as long as they are shorter than the length of the slit. Page number 27. Challenge. Reduce this angle. In the second figure, angle is reduced. In the third figure, the angle is still the same. 2.8 Special types of angles. Let us go back to Vidya's notebook and observe her opening the cover of the book in different scenarios. She makes a full turn of the cover when she has to write while holding the book in her hand. She makes a half turn of the cover when she has to open it on her table. In this case, observe the arms of the angle formed. They lie in a straight line. Such an angle is called a straight angle. You can find a picture on this page for a straight line. Let us consider a straight angle AOB. Observe that any ray OC divides it into two angles, angle AOC and angle COB. Page number 28. You can find two pictures given here. Is it possible to draw OC such that the two angles are equal to each other in size? Let's explore. We can try to solve this problem using a piece of paper. Recall that when a fold is made, it creates a crease which is straight. Take a rectangular piece of paper and on one of its sides mark the straight angle AOB. By folding, try to get a line, that is crease, passing through O that divides angle AOB into two equal angles. How can it be done? We can find some pictures on this page. Fold the paper such that OB overlaps with OA. Observe the crease and the two angles formed. Page number 29. Justify why the two angles are equal. Is there a way to superimpose and check? Can this superimposition be done by folding? Each of these equal angles formed are called right angles. So, a straight angle contains two right angles. Why shouldn't you argue with a 90-degree angle? Because they are always right. A beautiful picture shown here. If a straight angle is formed by half of a full turn, how much of a full turn will form a right angle? Observe that a right angle resembles the shape of an L. An angle is a right angle only if it is exactly half of a straight angle. Two lines that meet at right angles are called perpendicular lines. Figure it out. Question number 1. How many right angles do the windows of your classroom contain? Are there right angles in your classroom? Page number 30. Question number 2. Join A to other grid points in the figure by a straight line to get a straight angle. What are all the different ways of doing it? You find some pictures of grids on this page. Question number 3. Now join A to other grid points in the figure by a straight line to get a right angle. What are all the different ways of doing it? Try them on the given grids here. Hint: extend the line further as given in the figure here. To get a right angle at A, we need to draw a line through it that divides the straight angle CAB into two equal parts. Page number 31. Question number 4. Get a slanting crease on the paper. Now try to get another crease that is perpendicular to the slanting crease. Part A. How many right angles do you have now? Justify why the angles are exact right angles. Part B. Describe how you folded the paper so that any other person who doesn't know the process can simply follow your description to get the right angle. Classifying angles. Angles are classified in three groups as given here. Right angles are in the second group. You can find here what could be the common feature of the other two groups. In the first group, all angles are less than right angle, or in other words, less than a quarter turn. Such angles are called acute angles. In the third group, all angles are greater than a right angle but less than a straight angle. The turning is more than a quarter turn and less than a half turn. Such angles are called obtuse angles. Figure it out. Question number 1. Identify acute, right, obtuse and straight angles in the previous figures. Question number 2. Make a few acute angles and a few obtuse angles. Draw them in different orientations. Page number 32. Question number 3. Do you know what the words acute and obtuse mean? Acute means sharp and obtuse means blunt. Why do you think these words have been chosen? Question number 4. Find out the number of acute angles in each of the figures here. We have 3 pictures, different triangles. What will be the next figure and how many acute angles will it have? Do you notice any pattern in the numbers? 2.9 measuring angles. How to compare two angles? But can we actually quantify how big an angle is using a number without having to compare it to another angle? How various angles can be compared using a circle? Perhaps a circle could be used to assign measures for angles. We can find 2 pictures here to find out about various angles. To assign precise measures to angles, mathematicians came up with an idea. They divided the angle in the center of the circle into 360 equal parts or angles. The angle measure of each of these unit parts is 1 degree, which is written as 1 with a circular sign on the top. Page number 33. This unit part is used to assign measure to any angle. The measure of an angle is the number of 1 degree unit parts it contains inside it. For example, you can find in the figure here. It contains 30 units of 1 degree angle, and so we say that its angle measure is 30 degrees. Measures of different angles. What is the measure of a full turn in degrees? As we have taken it to contain 360 degrees, its measure is 360 degrees. What is the measure of a straight angle in degrees? Any straight angle is half of a full turn. As a full turn is 360 degrees, a half turn is 180 degrees. What is the measure of a right angle in degrees? 2 right angles together form a straight angle. As a straight angle measures 180 degrees, a right angle measures 90 degrees. In the pictures given here, a pinch of history. A full turn has been divided into 360 degrees. Why 360? The reason why we use 360 degree today is not fully known. The division of a circle into 360 parts goes back to ancient times. Page number 34. The Rig Veda, one of the very oldest texts of humanity going back thousands of years, speaks of a wheel with 360 spokes. Within brackets, verse 1.164.48. Many ancient calendars, also going back over 3000 years, such as calendars of India, Persia, Babylonia, and Egypt, were based on having 360 days in a year. In addition, Babylonian mathematicians frequently used divisions of 60 and 360 due to their use of sexagesimal numbers and counting by 60s. Perhaps the most important and practical answer for why mathematicians over the years have liked and continued to use 360 degrees is that 360 is the smallest number that can be evenly divided by all numbers up to 10, aside from 7. Thus, one can break up the circle into 1, 2, 3, 4, 5, 6, 8, 9 or 10 equal parts and still have a whole number of degrees in each part. Note that 360 is also evenly divisible by 12, the number of months in a year, and by 24, the number of hours in a day. These facts all make the number 360 very useful. The circle has been divided into 1, 2, 3, 4, 5, 6, 8, 9, 10 and 12 parts. What are the degree measures of the resulting angles? Write the degree measures near the indicated angles. You can find the pictures here. Degree measures of different angles. How can we measure other angles in degrees? It is for this purpose that we have a tool called a protractor, that is either a circle divided into 360 equal parts as given in the figure 2.12 on page 32, or a half circle divided into 180 equal parts. Page number 35. Unlabeled protractor. Here is a protractor. Do you find the straight angle at the center divided into 180 units of 1 degree? Only part of the lines dividing the straight angle are visible, though. Starting from the marking on the rightmost point of the base, there is a long mark for every 10 degrees. From every such long mark, there is a medium-sized mark after 5 degrees. Figure it out. Question number 1. Write the measures of the following angles. Part A. Angle KAL. You can find in the picture. Notice that the vertex of this angle coincides with the angle of the protractor. The number of units of 1 degree angle between KA and AL gives the measure of angle KAL. By counting, we get angle KAL is equal to 30 degrees. Making use of the medium-sized and the large-sized marks, is it possible to count the number of units in fives or tens? Part B. Angle WAL. Part C. Angle TAK. Page number 36. Labeled protractor. This is a protractor that you find in your geometry box. It would appear similar to the protractor indicates, except that there are numbers written on it. Will this make it easier to read the angles? You can find a picture of protractor here. There are two sets of numbers on the protractor, one increasing from right to left and the other increasing from left to right. Why does it include two sets of numbers? Question. Name the different angles in the figure and write their measures. We can find a picture and answer. Page number 37. Did you include angles such as angle TOQ? Which set of markings did you use? Inner or outer? What is the measure of angle TOS? Can you use the numbers marked to find the angle without counting the number of markings? Here, OT and OS pass through the numbers 20 and 55 on the outer scale. How many units of 1 degree are contained between these two arms? Can subtraction be used here? How can we measure angles directly without having to subtract? Place the protractor so the center is on the vertex of the angle. Align the protractor so that when the arms passes through the 0 degree mark as in the picture here. What is the degree measure of angle AOB as given in the picture? Make your own protractor. You may have wondered how the different equally spaced markings are made on a protractor. We will now see how we can make some of them. First step, draw a circle of a convenient radius on a sheet of paper. Cut out the circle. Figure 2.13. A circle or one full turn is 360 degrees. Second step, fold the circle to get two equal halves and cut it through the crease to get a semicircle. Write 0 degrees in the bottom right corner of the semicircle. Page number 38. You can find three figures depicting the fold of a circle forming a protractor. In figure 2.14, you can find 0 degrees and 180 degrees marked. The measure of half a circle is 1 by 2 of a full turn. Figure 2.14. So, the measure of half a turn is equal to half of 360 degrees, that is equal to 180 degrees. Thus, write 180 degrees in the left bottom corner of the semicircle. Third step, fold the semicircular sheet in half as you find in picture 2.15 to form a quarter circle. The measure of a quarter circle is 1 by 4 of a full turn. The measure of a 1 by 4 turn is equal to 1 by 4 of 360 degrees, that is equal to 90 degrees. Or the measure of a 1/4 turn is equal to half of a half turn, that is equal to half of 180 degrees, that is equal to 90 degrees. Thus, mark 90 degrees at the top of the semicircle. Page number 39. Fourth step, fold the sheet again as you find in the figure 2.16 and 2.17. When folded, this is 1/8 of the circle or 1/8 of a turn or 1/8 of 360 degrees or 1/4 of 180 degrees or 1 by 2 of 90 degrees. That is equal to 45 degrees. The new creases formed give us measures of 45 degrees and 180 degree minus 45 degree, that is equal to 135 degrees. Write 45 degrees and 135 degrees at the correct places on the new creases along the edge of the semicircle. Step 5. Continuing with another half fold as you find in the figure 2.18, we get an angle of measure. You need to fill the angle here. Step 6. Unfold and mark the creases as OB, OC, etc. as you find in the figure 2.19 and figure 2.20. Page number 40. Think. In figure 2.20, we have angle AOB is equal to angle BOC is equal to angle COD is equal to angle DOE is equal to angle EOF is equal to angle FOG is equal to angle GOH is equal to angle HOI is equal to dash. Y. Angle bisector. At each step, we fold it in halves. This process of getting half of a given angle is called bisecting the angle. The line that bisects a given angle is called the angle bisector of the angle. Identify the angle bisectors in your handmade protractor. Try to make different angles using the concept of angle bisector through paper folding? Figure it out. Question number 1. Find the degree measures of the following angles using your protractor. See the figures given here and find the degree measures. Question number 2. Find the degree measures of different angles in your classroom using your protractor. Teacher's note. It is important that students make their own protractor and use it to measure different angles before using the standard protractor so that they know the concept behind the marking of the standard protractor. Page number 41. Question number 3. Find the degree measures for the angles given below. Check if your paper protractor can be used here. Question number 4. How can you find the degree measure of the angle depicting using a protractor? Question number 5. Measure and write the degree measures for each of the depicting given here in part A and part B. Page number 42. We have part C, part D, part E and part F with different angles. Question number 6. Find the degree measures of angle BXE, angle CXE, angle AXB and angle BXC. Question number 7. Find the degree measures of angle PQR, PQS and angle PQT in the given figure. Page number 43. Question number 8. Make the paper craft as per the given instructions. Then unfold and open the paper fully. Draw lines on the creases made and measure the angles formed. You find 8 different pictures here. Question number 9. Measure all 3 angles of the triangle given in the figure 2.21a and write the measures down near the respective angles. Now add up the 3 measures. What do you get? Do the same for the triangles in the figure 2.21b and c. Try it for other triangles as well and then make a conjecture for what happens in general. We will come back to why this happens in a later year. You can find 3 different pictures given in figure 2.21. Page number 44. Mind the mistake, mend the mistake. A student used a protractor to measure the angles as given in each figure. Identify the incorrect usages of the protractor and discuss how the reading could have been made and think how it can be corrected. In the first one, you can find angle U is equal to 35 degrees. In the second figure, it represents angle V is equal to 80 degrees. In the next, angle W is equal to 70 degrees. Angle X is equal to 150 degrees. In the next, angle Y is equal to 120 degrees. And in the next picture, angle Z is equal to 85 degrees. Page number 45. Figure it out. Where are the angles? First question. Angles in a clock. Part A. Hands of a clock make different angles at different times. At 1 o'clock, the angle between the hands is 30 degrees. Why? Part B. What will be the angle at 2 o'clock and at 4 o'clock and at 6 o'clock? Part C. Explore other angles made by the hands of a clock. Question number 2. The angle of a door. Is it possible to express the amount by which a door is opened using an angle? What will be the vertex of the angle and what will be the arms of the angle? In the picture given on the page for question number 2. Question number 3. Vidya is enjoying her time on the swing. She notices that the greater the angle with which she starts the swinging, the greater is the speed she achieves on her swing. But where is the angle? Are you able to see any angle? In the picture given on this page, page number 46. Question number 4. Here is a toy with slanting slabs attached to its sides. The greater the angles or slopes of the slabs, the faster the balls roll. Can angles be used to describe the slopes of the slabs? What are the arms of each angle? Which arm is visible and which is not? Find out from the picture. Question number 5. Observe the images from the picture where there is an insect and its rotated version. Can angles be used to describe the amount of rotation? How? What will be the arms of the angle and the vertex? Hint is observe the horizontal line touching the insects. Teacher's note. It is important that students see the application of each mathematical concept in their daily lives. Teacher can organize some activities where students can appreciate the practical applications of angles in real life situations. Examples: clocks, doors, swings, concepts of uphill and downhill, location of the sun, the giving of directions, etc. 2.10. Drawing angles. Vidya wants to draw a 30-degree angle and name it angle TIN using a protractor. In angle TIN, I will be the vertex. IT and IN will be the arms of the angle. Keeping one arm, say IN, as the reference base, the other arm IT should take a turn of 30 degrees. Page number 47. Step 1. We begin with the base and draw IN as you can find in the picture. Step 2. We will place the center point of the protractor on I and align IN to the zero line as you can find in the picture. Step 3. Now, starting from 0, count your degrees. 0, 10, 30 up to 30 on the protractor. Mark point T at the label 30 degrees. Step 4. Using a ruler, join the point I and T. Angle TIN is equal to 30 degrees is the required angle, as you can find in the picture. Page number 48. Let's play a game. Game number 1. This is an angle guessing game. Play this game with your classmates by making two teams, Team 1 and Team 2. Here are the instructions and rules for the game. Team 1 secretly chooses an angle measure, for example 49 degrees, and makes an angle with that measure using a protractor without Team 2 being able to see it. Team 2 now gets to look at the angle. They have to quickly discuss and guess the number of degrees in the angle without using a protractor. Team 1 now demonstrates the true measure of the angle with a protractor. Team 2 scores the number of points, that is, the absolute difference in degrees between their guess and the correct measure. For example, if Team 2 guesses 39 degrees, then they score 10 points. 49 degrees minus 39 degrees. Each team gets 5 turns. The winner is the team with the lowest score. Let's play a game number 2. We now change the rules of the game a bit. Play this game with your classmates by again making 2 teams, Team 1 and Team 2. Here are the instructions and rules. Page number 49. Team 1 announces to all an angle measure example 34 degrees. A player from Team 2 must draw that angle on the board without using a protractor. Other members of the Team 2 can help the player by speaking words like make it bigger or make it smaller. A player from Team 1 measures the angle with a protractor for all to see. Then Team 2 scores the number of points, that is the absolute difference in degrees between Team 2's angle size and the intended angle size. For example, if player's angle from Team 2 is measured to be 25 degrees, then Team 2 scores 9 points. Difference of 34 degrees and 25 degrees. Then each team gets 5 turns. The winner is again the team with the lowest score. Teacher's note. These games are important to play to build intuition about angles and their measures. Return to this game at least once or twice on different days to build practice in estimating angles. Note that these games can also be played between pairs of students. Figure it out. Question number 1. In figure 2.23, list all the angles possible. Did you find them all? Now, guess the measures of all the angles. Then, measure the angles with a protractor. Record all your numbers in a table. Observe how close your guesses are to the actual measures. As you can find figure 2.23, which is given here. Page number 50. Question number 2. Use a protractor to draw angles having the following degrees measures. Part A 110 degrees, Part B 40 degrees, Part C 75 degrees, Part D 112 degrees, Part E 134 degrees. Question number 3. Draw an angle whose degree measure is the same as given in the figure. Also, write down the steps you followed to draw the angle. 2.11. Types of angles and their measures. We have read about different types of angles in this chapter. We have a straight angle is 180 degrees and a right angle is 90 degrees. How can other types of angles, acute and obtuse, be described in terms of their degree measures? Acute angle. Angles that are smaller than a right angle, that is less than 90 degrees and are greater than 0 degrees, are called acute angles. As given in the pictures, there are some examples of acute angles. Page number 51. Obtuse angle. Angles that are greater than the right angle and less than the straight angle, that is greater than 90 degrees and less than 180 degrees, are called obtuse angles. As you can see in the examples of obtuse angles with figures here. Have we covered all the possible measures that an angle can make? Here is another type of angle. Reflex angle. Angles that are greater than the straight angle and less than the whole angle, that is greater than 180 degrees and less than 360 degrees are called reflex angles. You can see the examples of reflex angle in the pictures given here. Figure it out. Question number 1. In each of the given grids, join A to other grid points in the figure by a straight line to get an acute angle. Page number 52. With the help of the grids, try to make an acute angle. Part C. A reflex angle. Mark the intended angles with curves to specify the angles. One has been done for you. Question number 2. Use a protractor to find the measure of each angle. Then classify each angle as acute, obtuse, right or reflex. Part A. Angle PTR. Part B. Angle PTQ. Part C. Angle PTW. Part D. Angle WTP as given here. Page number 53. Let's explore. In this figure, angle TER is equal to 80 degrees. What is the measure of angle BET? What is the measure of angle SET? You can find a picture given here. Hint is observe that angle REB is a straight angle. Hence, the degree measure of angle REB is equal to 180 degrees, of which 80 degrees is covered by angle TER. A similar argument can be applied to find the measure of angle SET. Figure it out. Question number 1. Draw angles with the following degree measures. Part A 140 degrees, Part B 82 degrees, Part C 195 degrees, Part D 70 degrees, Part E 35 degrees. Question number 2. Estimate the size of each angle and then measure it with the protractor. In the figures given here on this page in different parts A, B, C, D, E and F. Classify these angles as acute, right, obtuse or reflex angles. Question number 3. Make any figure with 3 acute angles, 1 right angle and 2 obtuse angles. Question number 4. Draw the letter M such that the angles on the sides are 40 degrees each and the angle in the middle is 60 degrees. Question number 5. Draw the letter Y such that the 3 angles formed are 150 degrees, 60 degrees and 150 degrees. Page number 54. Question number 6. The Ashok Chakra has 24 spokes. What is the degree measure of the angle between 2 spokes next to each other? What is the largest acute angle formed between 2 spokes? Question number 7. Puzzle. I am an acute angle. If you double my measure, you get an acute angle. If you triple my measure, you will get an acute angle again. If you quadruple 4 times my measure, you will get an acute angle yet again. But if you multiply my measure by 5, you will get an obtuse angle measure. What are the possibilities for my measure? Summary. A point determines a location. It is denoted by a capital letter. A line segment corresponds to the shortest distance between 2 points. The line segment joining points S and T is denoted by ST. A line is obtained when a line segment like ST is extended on both sides indefinitely. It is denoted by ST or sometimes by a single small letter like M. A ray is a portion of a line starting at a point D and going in one direction indefinitely. It is denoted by dp, where p is another point on the ray. An angle can be visualized as two rays starting from a common starting point. Two rays OP and OM form the angle POM, also called angle MOP. Here, O is called the vertex of the angle, and the rays OP and OM are called the arms of the angle. The size of an angle is the amount of rotation or turn needed about the vertex to rotate one ray of the angle onto the other ray of the angle. The sizes of angles can be measured in degrees. One full rotation or turn is considered as 360 degrees and denoted as 360 degrees. Degree measures of angles can be measured using a protractor. Angles can be straight 180 degrees, right 90 degrees, acute more than 0 degrees and less than 90 degrees, obtuse more than 90 degrees and less than 180 degrees, and reflex more than 180 degrees and less than 360 degrees. Chapter 2 ends here.
Ganit Prakash. You were just listening to this audio book, Textbook of Mathematics for Grade 6. Narration Swarnlata. Academic Coordinator Dr. Prakash Vadigar. Technical Coordination Bati Langlingdo. Sound Recordist Vikas Sangwan. Assistance in Production Surendra Kumar. Directed and produced by Vimlesh Chaudhary. This audiobook is presented to you by CIET NCERT, New Delhi, India.